the first thing I would have to do for any stoichiometry problem, I have to have an equation, I have to have a balance, right? So what do I need to do to balance it? Oxygen's not balanced, so I'm going to need 2 waters, right? Calcium is good.
But now you have too much height.
I have 4 hydrogens here. I have 2 here and 2 more here, so 4 total, right? It's done. And so I am balanced. I just need 1 to finish the rest of the stuff. But otherwise, I just start with whatever I'm given. 2.5 grams of calcium is dropped into that water. What mass of calcium hydroxide would be formed as a result? So I start with 2.5 grams of calcium. But the first thing I'm going to actually have to do every time is change grams into moles. Because I can only relate moles one thing to moles of another. I can't go directly from grams of calcium to grams of calcium hydroxide. I have to have moles to be able to relate those things. Because they're in a 1-to-1 ratio, right? So only in moles. 2.5 grams of calcium doesn't make 2.5 grams of calcium hydroxide. Right? Because there'd be 2.5 grams of calcium in here, right? But there'd be more mass for the hydroxide. So I have to ultimately take whatever I'm given, grams in this case, I need to turn it into moles so that I could turn that into a different mole, right? Relate moles to other moles. Then maybe I can come up with a mass, right? So I always write out this thing up here in general, just as scratch to work off of. Because from here, I'm literally just going to figure out what was given to me. I'm always given something on the left side, and I want something on the right side, right? I could have been given moles of calcium, but I wasn't. I was given grams. So you just have to do however much work you have to do. I need to go from grams on the left all the way to grams on the right, and I should actually be able to tell what my work's going to look like, because I need a gram here to cancel the gram there, right? I need a mole here to cancel a mole there. I need a mole here to cancel moles there. And those things, those conversion factors in that work that I just drew out, that little, it's not even work, it's just a template for me to work out with every time, to understand what do I need to do to get my answer. And those things correspond with molar masses, like in the first step. What is the mass for 1 mole of calcium? 40.08 grams per mole. So I effectively just change grams of calcium into moles of calcium, right? So that's not my last step of this problem. I don't find the answer right now. I wait until I get everything set up. The next thing I'm supposed to do is a ratio, right? Now, currently, I have moles of calcium. I want moles of calcium hydroxide, since that's what I'm ultimately trying to get in this problem. So I have to do a ratio between these things, which in this case is easy because it's 1-to-1, right? But if it's not 1-to-1, then you have to deal with that. Now, in your work, you would always put the 1-to-1, even if it is, right? But multiplying and dividing by 1 isn't going to change anything. So we know that this is effectively not doing anything math-wise in this case. But I need to understand that I'm canceling one label to get another label, right? I'm not talking about moles of calcium anymore. Now I'm talking about moles of calcium hydroxide. And most of the time there isn't a 1-to-1 ratio. So you do end up changing your answer because of the math. So then, again, I have to do one last step over here because I don't want moles of calcium hydroxide. I want a mass of that. So again, mole goes on the bottom. 1 mole is how many grams per calcium hydroxide. Add up all those pieces. Remember, there's 2 hydroxides. So that's a 34.02 plus the calcium. So what, it's going to be like 74.10? And if I work this out, it should give me my answer that I'm supposed to get. In grams, it's calcium hydroxide still, that's why I didn't cross out that part of the label. So what's 2.5 times 74.10 divided by 40.08? You can do it in whatever order you want. You can go 2.5 divided by 40.08 and then multiply by 74.10.
I got 4.6.
I only need 266, so we'll change that to just 4.6. You put a label on it that it's calcium hydroxide, grams of calcium hydroxide, and that'd be my answer for this. So everybody got 4.6. So then, next one, same thing, just going to be different ratios and whatnot, because I'm talking about calcium versus the precipitate, which is the calcium hydroxide, right? So actually, this is the exact same problem, right? It says if 1.75 grams of precipitate, solid product, is formed from what mass of calcium is reacted. It's basically the same question, just backwards, right? Because I'm giving you this mass first, and then you try to come up with that one, right? So it's all the same stuff, just backwards. I start with 1.75 grams, but instead of using this molar mass, I use that molar mass. But again, I have to make it look like this one. I have to divide by grams, right? So I'm going to be dividing by 74.10 grams per mole. Because again, that's how I change grams into moles. Then I can relate moles to one another. This again is just a 1-to-1 ratio, right? So that part's easy. But you still got to put it in here, 1 mole, 1 mole. Because effectively I'm changing my label. Right? It was a label of calcium hydroxide here, but I want it to be calcium instead. So I'm canceling moles with moles. And then my last step would be to multiply by the mass, but it's going to be this mass. So just take that, flip it, right? But again, same idea. Take that 1.75, multiply it by 40.08, and then divide by 74.10. We get 1. It should be smaller than 1.75. Not quite half, maybe somewhere around 0.9. 0.94. And I assume you're saying 266, that rounds up to 0.95? That's why it's not a 4. So that's how many grams of calcium would have had to have reacted. Again, you should put your label on your mass, because then you know which thing you came up with, what you were doing. Oh, I do need 366. That's one is different. Uh-oh, can't do that. 0.947 then? Dang it. Push back to the marker. There we go. Got that one. Next one. Says what volume of water, milliliters, would be required to react with 5 grams of calcium. So this time, finally, I'm not going to have a 1-to-1 ratio, so we'll see how that actually affects it. Okay? But, so it is a 1-to-2 ratio of calcium to water. Let me see something with this so I can make it easier. But what volume of water would be required to react with 5 grams of calcium? Just start with whatever they gave you, 5 grams of calcium. So I got to change grams into moles. What's my molar mass for calcium again? That's 3%. And do I multiply or divide by that? Divide. That'll give me my moles. Moles of calcium, right? So now I need a ratio. What is my ratio again? It's 2 to 1, 1 to 2. Right? One or the other. Where do I need which label? but I got calcium here.
Calcium on the bottom.
So the calcium has to go down here, which was a 1, right? The 2 went with the water, so I know which one to put where because I gotta make things work. If I gotta cancel this molten calcium, that's where that needs to go on the bottom. Molten water goes on the top. And then last step would be to change that mole that I have into grams. What is the molar mass for water, guys? We did it on the other worksheet with you. You did use it, it's 18.02. We use that one a lot, so you're probably gonna memorize it. It's kinda like if we did sodium hydroxide right now, I could tell you it's 40.00. It happens to be an even number, and I've used it a lot of times, so I know what it is. Now, I had this add up to calcium hydroxide, because I don't use that very often. But some things will do enough that you'll be like, oh yeah, it's supposed to be 18.02. Water we use all the time for this kind of purpose, but multiplying, dividing, right, this 2 is a factor now, right? So I'm going to multiply 5 times 2, which is actually just 10, which makes this 180, right? 180 divided by 40. Just as an estimate, would be a little bit bigger than 4, right? So 4.5, 4.5. What is that? 4.49. 4.49? Somewhere 4.5. Usually 4.5. 4.5? With 2 sig figs, you just round appropriately, 4.5 grams of water, right? Now, did I ask for grams? Could ask for milliliters, right? So do I really have to convert it? We talked about density of water already, didn't we? We're talking about density in the very first chapter, right? Density of water is exactly 1 gram per milliliter, right? That means if I have 4.5 grams, how many milliliters do I have? If I had 87.5 grams, it would be how many milliliters? It would be 87.5. All I have to do is just write my label different. I mean, since we know that's the way it is for water all the time, just do that. That's fine. And otherwise, you could put a conversion factor in here too that was 1 to 1, right? 1 milliliter over 1 gram in this case to change the label. But you should get used to that. I'll do that a lot. Because sometimes I'll tell you how many milliliters of water you have, and you really need to know how many grams you have. And I'm not intending to trick you necessarily, but I need you guys to get that through your head. Density of water, right? Milliliters is grams. Grams are milliliters for water. You don't have to worry about converting. You just need to know, oh, I do actually have grams. Or, okay, I got grams. That is the same as my milliliters in this case. You guys kind of understand how that would work? It's the same kind of stuff every time, right? If you can do that whole process, you should be okay. Again, I always start out by thinking, okay, what part of this do I need to do? And we could get to the point where I do different stuff. I'm going to do a lot of the same things for you guys because we're not going to spend a ton of time on this. But if you're in Gen Chem and you're doing the same thing, stoichiometry, a lot of times you're going to start with moles in 1 gram. So I just wouldn't need the first step, right? If you were given moles and you wanted grams, I would need to get all the way from here to there, but I would just be doing a mole ratio and then multiplying by a molar mass, because that's all I have to do, right? The first step is no longer necessary, right? You have to be given something on the left, because it's got to be something A being converted into something B, right, at some point or another, or else it's not a stoichiometry problem, right? So you have to be given grams or moles of A, and you have to need, for an answer, moles or grams of B, but sometimes you just want moles of B, and you're given moles of A. And it's just a single ratio. It's easy, right? But you have to do some portion of this template, and usually you'll do the whole thing. So if I was given grams of A again, I'd have to put gram here. You divide by a molar mass, you'd use a ratio, and then you'd multiply by a molar mass. That's why I use this template, because you know what it's supposed to look like, right? you know that you're gonna have some number here of grams per mole, and that depends on the substance. What is it, right? Use your periodic table. This is always 1 mole though, right? Here, this ratio is dependent, right? You'll get this out of your balanced equation. You just have to make sure the right thing is in the right place. Because here, this should be A, and this should be B, right? I don't know what A is, but I was given moles or grams of A, and I need to change it into moles or grams of B. So make sure you put the numbers in the right place. But if it's 1-to-1, this is hardly necessary in terms of the math. You still have to do it though, because then you can have the label switch. Whereas over here, I need to have an amount of grams for B, some molar mass, right? This comes off your periodic table. This is always 1 mole though, right? Some people get caught up in that. It'll say 2 moles of B here, so they think, oh, 2 moles of B is this mass, right? It's always 1 mole, right? You could do 2 moles of B, but then you'd have to double the mass. You'd have to add it up and double it and make it twice as big, but why do that? It doesn't, that's extra work for no reason, because you're still going to divide by 2 if that's the case, right? So you just wasted some time. It's always 1 mole for our molar masses, but this number, whatever it is, for A or B comes off the periodic table. Whereas these numbers come from your equation, right? Your balanced equation. So you guys should be able to try those examples on the back real quick. Do number 2 on the back, balance that equation, figure it out, and we'll see if we can handle that.